Okay, so I think there's an issue with my camera, but that's fine. I think we can get started. Hello, everyone, and welcome to another exciting session at the AI Summer of Code 2.0. Okay, yeah, so I think there seems to be an issue with my camera right now. It's giving me this information sign. But yeah, we can get started. Let's see. Okay, so yeah, we can get started. Hello, everyone. Welcome once again to the AI Summer of Code. Today's session is going to be super exciting. It's one I consider really exciting for our learning journey. And we have two amazing individuals who are going to be taking us through this particular learning. I'm just going to, for those of us who are just joining or who did not really look into the group chat before joining on, right? We have both Emeli and Elena on the call with us today, and they will be taking over in the next few minutes. But before then, I'd like to give a brief about who they are, and just so we are aware of why exactly we have them on this particular program. Right. So first off, we have Elena. See.
Hello, everyone.
So yes, please give me a minute. I'm trying to fix my slide. Not sure why this isn't coming up top. Okay, yeah. So first off, we have Elena. Elena is the CEO and co-founder at Evidently AI. She has been active in the applied machine learning space since 2014. Previously, she co-founded and served as a CPO of an industrial AI startup. She also worked with global metal and chemical companies to implement machine learning for production optimization. Prior to that, she led business development at Yandex Data Factory, an enterprise AI division of Yandex. She focused on delivering machine learning-based solutions to retail, banking, telecoms, and other industries. In 2018, Elena was named amongst the top 50 women in product Europe by Product Management Festival. Now, this is a very exciting. Everyone, please put your hands together for Elena. I'm also going to read through for Emeli. Now, Emeli is also a co-founder at Evidently AI alongside Elena. She's also the CTO at Evidently AI, a Y Combinator-backed startup, developing AI observability tools to evaluate, test, and monitor the quality of AI systems. Of course, some of us at the end of the day, right, our systems will have to go through Evidently products built by Evidently AI. Amazing. Earlier on, Emeli focused, she co-founded an industrial AI startup and served as the chief data scientist at Yandex Data Factory as well. She led over 50 applied machine learning projects for various industries, from banking to manufacturing and many others as well. Emeli is a data science lecturer at GSOM, SPBU. I'm not sure, I don't have like a full for that, and Harbour Space University. She's also a co-author of the machine learning and data analysis curriculum at Coursera with over 150,000 students. Ladies and gentlemen, AISOC stars, please put your hands together for both Emeli and Elena. Their profiles are really amazing, and we're super excited to learn from them this afternoon. Hello, Elena. Hello, Emeli.
Hello, and thank you for a very nice introduction.
Right.
And we're very happy to be here. Thank you.
Welcome. Okay, so I'm going to stop sharing and you can take over.
Okay, so should we start, or do you want to go through any other logistics? I would take it as that we can start, correct? Could you please confirm that you could hear me well? Maybe someone can type it in the chat.
Yeah, we can
Yep,
see
yep,
you.
absolutely. Yeah.
Perfect. So thank you for a very nice introduction. As mentioned, my name is Elena, and my colleague and co-founder Emeli is also here. And we're going to split today the presentation between two of us. I'm going to go a little bit more over the theory and walk you through the slides, whereas Emeli is going to show live demo example of how you can run evaluations for RAG systems. So we're going to do it one after another. And I think we're going to have like 10 minutes in the end for questions. But I think it's great if you have any questions, you can type them in the chat so that we can later read them out loud. So that would be my expectation. Samuel, Zion, if you think something should be different, let me know. Otherwise, I'm going to start. So I'm going to share my screen now, and this will be the slide deck that I prepared. I hope you can see it. And let me walk through the topic that I want to cover today. So we're going to talk about evaluating RAG systems and, in general, LLM-powered systems. And here are a few things I want to talk about today. So first of all, a little bit about the basics of LLM evaluations, what it is, when you need it, why it matters. Then we're going to talk a bit more about the methods and how exactly you can implement this evaluation, specifically paying attention to the LLM as a judge approach, which is one of the more popular ways how you evaluate LLM systems these days. Then we're going to talk a little bit more about RAG, since that's the topic we announced, and summarize it with a few tips and learnings. And the most exciting part for me is actually see how it works in practice, which will be done by Emeli. So let's dive in. A little bit about why we are here today and why we're talking about LLM evaluations. I think you've already heard that me and Emeli have been working on machine learning for quite a while. And lately, we've been working on a company called Evidently AI, where we created an open source tool called Evidently, which is a Python library, which is free to use. You can download it, you can check it out on GitHub, give it a star, and you can use it to test and evaluate AI systems, starting from classic machine learning models, looking at the data or model outputs, to LLM-based systems. And on top of it, we have a product which is called Evidently Cloud, which is a complete web application that lets you manage the whole life cycle of evaluation, testing, and monitoring for your AI systems and collaborate as a team. So we've been around this topic for quite a while, and what we are sharing today is based on all this experience and all the projects that we worked on, be it in classic machine learning and LLM systems as well. So now let's talk about LLM evaluations. If you've been following the topic, you may know that LLM evaluations is a pretty big deal. In this case, like most of the conversations that are happening in the LLM evals is saying how important it is, right? So like everywhere you look, people will say like, you need evaluations. To build a good product, you need to have evals sorted out. I think the reality of why we do this and why we like it is that not because we really care about the evaluations per se, but rather because we want to make sure that the systems that we are building have good quality. And if you look for LLM evaluations and you Google for these words, the first thing you'll probably find is something called LLM benchmarks. In this case, LLM benchmarks are ways how we evaluate not LLM systems, but rather LLM models. In this case, like for example, is the new GPT-5 better than GPT-4 and by which dimension? Or maybe this new DeepSeek model was released, or this new alternative open source model is released. How is it better than another? And LLM benchmarks is what helps you compare different LLM models as they're being released between themselves, right? So that's a way how we can objectively compare which one is better than another. But if you're building an LLM system, like for example, you're a developer and you're working on a chatbot or any kind of LLM-powered application, that is useful, but that's probably not what you care about, because what you care about is how your exact system works. And if you look inside the benchmark, like what types of questions and tests are inside these public benchmarks, this is something like this. So for example, here is a question about like essentially what a monopoly is. It's good if your LLM sort of knows this, right, and it can answer these questions correctly. But in reality, that is not very useful if, for example, you're building a support chatbot, right? So you want to make sure that the chatbot answers the questions that are related to your use case, not what a monopoly is. And in this case, you need to evaluate your product, right? And your product can be, as I mentioned, a chatbot, maybe it can be a queue system, maybe it can be a summarization tool or anything like this. And you need to evaluate it all together with everything that you add on top of the model. So in this case, at the very least, typically you have a prompt, like a system prompt that you write on top of the LLM that basically instructs the LLM to operate in a certain way, right? So your evaluation will concern not just the model, but this model plus prompts. But depending on how you design your system, for example, if it's a RAG system, you're probably also going to give some access to data sources like knowledge databases and so on. Maybe you're going to implement some guardrails. Maybe you'll give access to tools if it's an agentic system. So here, when you talk about LLM system evaluation, you need to evaluate, well, this whole system. We are not testing if an LLM knows what a monopoly is. We are evaluating if the chatbot that you built gives correct answers within the domain that you want it to be used. So now that we clarified that, so let's talk about how, right? So we're talking about evaluating the systems. How exactly can we do this, and what exactly it looks like in practice? In fact, when we talk about evals, it's not one singular thing that we do, right? It's not just some standalone activity like doing evals. This is actually a workflow that fits into several stages of your LLM product development. And it usually starts with something that is used to be called experiment management in classic ML. So here we talk about the process when you are designing your system. You're maybe trying different models, you're comparing different prompts, and you need a way to make sure if you're getting better or maybe worse, or you're regressing when you're trying these different options. So for example, if I try a prompt A versus prompt B, which one is better? So here you need evaluations as a way to compare the quality on these different combinations to figure out which one is better. Then on top of it, you might also want to run something that is called adversarial or stress testing. That is usually not something that's top of mind when you're just building your system and you're trying to figure out like which vector database to use. But once you approach production use, and if it's a customer-facing system or you're working at a large enterprise company, that is typically becoming quite a big deal, because you want to make sure that the system is also safe when it comes to maybe edge cases or some sort of more adversarial inputs. That's not what you expect your users to do, right? You don't expect your users to come and break your system, but you know that these things can happen. So you need to make sure that the system you design will withstand all types of adversaries that it can meet. So for example, like what if you ask your chatbot to talk about competition, or maybe to swear on you or to do something that it shouldn't do? Will it actually comply or not? And if you follow the topic, there are quite a few examples of things already going wrong. So you can understand what type of risks we are dealing with here. So for example, here is a Chevrolet chatbot, which is just a customer-facing chatbot on the website. And one of the users came and asked this chatbot to sell a car for $1. And it agreed, because LLMs are very compliant. They're made to please the users, right? In this case, it generated a text which essentially said, sure, you can buy a car for $1. If you're building a chatbot that is operating on a business website, that's not the behavior that you want to do, right? Not something that you want to observe. And here's another use case. So DPD, which is a delivery company, which we know sometimes have issues with deliveries, and they had an unhappy user who basically interacted with the chatbot and made this chatbot swear and sing a song and claim how bad the company is. So this is a pretty bad brand perception result, right, for the company. Instead of having a helpful chatbot, they have a chatbot that actually swears at its own company. So again, you might want to test for this type of behaviors in advance, and then also like implement some ways to assert that this doesn't happen. And this is also part of the evaluation workflow. And one more thing to consider is also a variance in the answers that you can get. So for example, LLMs can generate different outputs even for the exact same input, right? Because there is some non-determinism involved. And for example, if you slightly vary the ways how you formulate your questions, you can also get different answers. And if you're operating in some very important and strict domain, you need to make sure that the answers will not vary when people do something slightly differently. Right, so we now spoke about the experimental evaluations and the stress testing and red teaming. But it doesn't stop here, right? So you also need evals when it comes to production. If you finally build the system, you put it into production, you're operating it in front of your users, you need to make sure that the users are getting good experience, and you need to understand how exactly they're using it, what type of questions are they asking, what type of responses are they getting, and so on. So here comes production monitoring. And last but not least, we also have regression testing. So if you're having any kind of change introduced to your system, like maybe you noticed a certain bug, or you decided that you want to change a prompt, or maybe add something else to your existing knowledge base because you have new documents to introduce to as a source, you need to regression test these changes, which means that after you make this change, you will run certain evaluations to make sure that you're not breaking some existing behaviors. If that sounds like a lot, it's because it is, right? So these evaluations are pretty much with you throughout the whole product lifecycle if you want to make sure that your systems are reliable in production. And here's one way how you can structure it if you're thinking about all these types of evaluations. Some of the evaluations that I introduced are happening offline, so experiments or regression tests or adversarial tests, meaning that you can run them separately from your production system. It can be a script, or it can be just a manual review, but it's a process that is happening outside your production system. And then there is production level evaluations where you actually work with real user logs and you're trying to understand what is the experience that users are getting. And when it comes to methods of evaluations, this also makes a big difference, because when you're talking about offline evals, you can prepare data sets in advance so that you will be comparing the answers that you get against the expected ones. And if you're running online evals, well, you don't have this luxury, so you'll be looking just at the data as it comes, and you need methods that let you assess the quality of the outputs without this reference ideal answer to compare to. Let's talk a little bit about the method. So I've already introduced this idea of reference-based and reference-free evals, so let's look at it a little bit more detail. So the reference-based evals or ground truth-based evals is something that is resembling our classic evaluations in machine learning when you have a fixed test data set with correct answers, and then you're trying to make sure that the system that you are building is able to match these answers. The only caveat here is that usually we are not looking here for an exact match, because LLMs can generate very open-ended outputs. For example, it can formulate the answer to a user query in slightly different ways. So you need to match the answers semantically, not necessarily just looking at an identical word-by-word match. And important thing here, it all starts with test data sets. So to make sure that the system is giving correct answers, you need to first devise these answers, right? So you need to design the type of questions that the users can ask. For example, if you have a chatbot, a financial chatbot or something like this, you have some idea about types of queries that the users might come up with. So you need to prepare a set of representative queries and a set of correct answers to this. In some cases, you can find this data somewhere. So maybe if you have like a customer support chatbot, and before that you already had a chatbot where real humans were interacting with your customers, you can actually go through the logs and design this type of ideal data set. Or you can just write it manually from scratch, especially if you understand the domain, and you can come up with some specific tricky questions or interesting ones to make sure that you can catch potential errors within the LLM responses. In some cases, you can also look at public benchmarks. This is usually related to some sort of like safety testing, which is not specific to the domain. And last but not least, we also have synthetic data. And this is the part that you can also use LLMs to help you with. In this case, you can ask LLMs to help you generate possible questions that the users can come up with so that you can later review them, and now you arrive to your test data set much faster than writing it all from scratch. So this is the idea of the reference-based evaluations. You design this as a test data set, and then you compare if the answers you're getting match it. And the other way is to go at reference-free evaluations. In this case, you don't have the correct answers, so you pretty much just need to generate some, if you're running test inputs, and then you need to figure out a way to evaluate the outputs that you get. Like, for example, are the responses polite or helpful or concise? In this case, it all starts with the definition of quality. And that's where it gets a little bit complicated, because depending on the type of system that you're building, quality can mean different things. So maybe it's more related to the factual accuracy of the responses. Maybe it has to match certain style or certain format, or maybe it's just needs to use correct tools if it's an agentic system. So in this case, the definition of quality is very much tied to the type of product that you're building, and it's sometimes hard to come up with it in advance. So in this case, you cannot just like theoretically prepare all the quality dimensions. So you typically need to first start by looking at the data and actually seeing like what type of errors your LLM is making, what issues you observe, so that you can observe these quality dimensions bottom up or specific error modes, and then you'll figure out what are the type of things that you pay attention to. As an example, we've been talking to one client where the company is building a tool that helps comment on code reviews. And the type of errors that they were getting is that sometimes LLM was generating code reviews that were like very cheerful, but not helpful at all, right? So they were not actionable. In this case, this might be the quality dimension that you might want to measure. So you need a way to evaluate, for example, actionability of generated code review. And as an obvious conclusion of that, typically you do start with manual labeling, and nothing wrong with manual labeling. Actually, it's amazing. The only problem with manual labeling and manually reviewing responses is that it doesn't scale. So you might start there, but eventually need to figure out to automate your evaluation, some sort of automated script, because otherwise you'll be stuck at every change and with the need to reevaluate everything that you're doing. I will not go very deeply into methods because there are a lot, and just to overwhelm you a little bit, here is a type of method that you can look at. If you're interested, maybe we can drop a link later. We have a huge blog about this. But I want to talk specifically about one method which is here in the center, which is called LLM as a judge. And I think that's a very fascinating method, though sometimes people at first look at it with some skeptical eye. The idea here is that you can use LLMs to help you evaluate your LLM outputs. Essentially, you're sending whatever you generated to another LLM or to the same LLM for this matter with an evaluation prompt and ask an LLM to score the response by certain criteria. So for example, you can say, hey, is this response polite or is this response concise? The idea is that you can essentially automate human labeling once you figure out your criteria and you narrow it down enough so that you can write a good evaluation prompt, and then you pretty much like outsource it to an LLM, just like you would have outsourced it to a human intern reviewing the responses. And you can do this actually in both reference-based and reference-free evaluation. So for example, in reference-based evaluation, you will be essentially asking LLM to match the two responses, like the ideal response and the response that you get, and return you a verdict, kind of like correct or incorrect or contradictory or not contradictory when it comes to the two responses. It is a replacement essentially for semantic similarity or for more old school metrics like BLEU and Rouge, which look at the overlap of words between the two texts. And this is very good for offline evaluations, right? Because to run this type of correctness evaluations, you need to have the ideal answer in advance, something like regression testing. And here's an example. I know it's probably not very readable, but it illustrates a nice idea. So here we have first the question, which is like a target questions, like why do we have seasons? Then we have a target response, which is in a pre-approved ideal response, something that we want our LLM to give. And then we have a real response that we supposedly get from an LLM after we run this question through it. And then we have two LLM judgments, which are generated using LLM as a judge. One is looking for contradictions. So essentially, it's looking to check if there is any contradiction between the answer we got and the answer we wanted to get. Another one is looking for style match, essentially looking, for example, if the level of verbosity or conciseness is the same between the two answers. And this is a good illustration that you can actually customize the criteria. Even if we talk about like this matching of the two responses, this can mean different things, right? Style match, a correctness match, or maybe you want to look at omissions or contradictions. So you can actually clarify this in your evaluation prompt. And the second approach with LLM Judge is reference-free, right? So this is the one that I described initially. Here, we're not comparing the two responses, but we're just like looking at the one response that we got, and then we're asking to assess it by some criteria. And this can be any criteria, like is the tone professional, or does it match a certain format, and so on. Of course, we cannot really ask for additional judgment on the same question that was originally asked, like essentially like asking the LLM to answer the answer again. We are trying to look at some specific criteria or property that is easy to assess when you delegate it to an LLM. So something like, for example, does this answer contain anything that resembles personal information? This type of question is something that LLM can deal with very nicely. And an interesting property of this approach that you can also feed the whole conversation, something like the whole transcript, for example, an exchange between the user and the chatbot, and also ask the LLM Judge to read it and come up with a certain conclusion, something like, did at any point of this conversation the user express frustration or wasn't happy? So that's a very interesting approach for session level evaluations of LLM judges. The caveat with this LLM judgment approach is that you actually need to evaluate your judge. It's like a small machine learning project in itself. Basically, the idea is to automate your labeling, right? Labeling is typically a classification problem, maybe binary, maybe multi-class. So the best way to come up with a working good LLM judge is to first be the labeler. So come up with the judgments the way you want the LLM later do the same, right? And then write a prompt and try to match the responses that you get from LLM against the answers that you have. So for example, here is like a simple illustration. So I already brought up this example of code reviews. So let's assume that we have these code reviews that were generated by the LLM. Then we ask a human to grade them as good or bad and explain why they're good or bad. So this is like our ideal labels that we want our LLM judge to match. And then we can go and write a judge prompt. So in this case, this is the instruction that explains to the LLM how we should be labeling the responses, where you try to mimic, as a result, the labels that the human was given originally. And then you can run it through the same example that the human already labeled, right? And look at the LLM judgments and labels and compare them against humans. So this sounds a little bit tedious first, but this is the best way to actually get reliable LLM judges. Of course, you can first just look at the results you get and then think it over. But if you want to trust your judge, it's better to also like treat it as a small machine learning project in itself. As a very quick tips, I think like everything that applies for LLM judges is the same thing that generally applies to writing prompts. Be clear, keep things simple. If you have multiple criteria, break it down. In this case, you don't have to have one singular LLM judge. You can actually have multiple LLM judges, even for the same output. You can just ask each judge to judge something specific. And in this case, you would have like more clarity and more ease in comparing the labels against humans and just in general trusting the judge that you created. You can even consider the idea of LLM juries, which I find very fun. In this case, you basically use multiple LLMs to do the same judgments, and then you can join their judgments in a certain way, like either look at the majority vote or maybe combine them in a certain way. And if you're interested, we also have a blog about this where we asked different LLMs to judge if an email is appropriate in the workplace communication. And then you can see that there is like some variance in how, for example, Gemini versus GPT versus Anthropic make these judgments. And sometimes it's useful if you're dealing with some very nuanced criteria. We or even humans sometimes can disagree. To summarize all this, let's try to quickly apply it to the RAG system before we go to the actual illustration. So the same ideas that I just walked you through, right? So the reference-based and reference-free evaluations and using LLM judges can be applied specifically to RAG systems. As a quick reminder, when we talk about RAG, we talk about a system where we are not just using the LLM knowledge, whatever it was trained on, and the data that is so in training to give the answers, but we rather provide a certain knowledge base, additional information to the LLM to generate the responses. A very classic example is support chatbot, where you provide some sort of knowledge base of help articles to help the LLM formulate the answer. And when it comes to RAG, it essentially has two parts of it, right? So the first one is retrieval, and the second one is generated. That's why we call it RAG. And the first one is where you try to find the correct documents or chunk of document inside your database to formulate the answer. And the second one is where you actually formulate the answer. So if we try to be very thorough when we want to evaluate RAG, we can actually evaluate both the sides separately, right? So retrieval and generation. In each case, we're going to be focused on the quality of this part specifically, because sometimes the problem is that you cannot find the document that you need to use, and sometimes you can find this document, but maybe you cannot use it effectively. However, in many simple RAGs, you don't really need to do all this unless you actually face certain problems. So the first step where you can start is looking at the quality of the final response, right? In this case, basically focusing on the quality of the final generation, and then maybe looking at the retrieval quality if you feel that this is the source of the problem. And in this case, same things apply, right? So we have the ground truth-based and open-ended evaluation. And in ground truth-based evaluations, we actually have a luxury that we don't usually have in many other LLM applications that can help us generate the evaluation data set. In this case, because you already have a knowledge base, which you're going to be using for your RAG, you can actually use the same knowledge base, I mean, the documents, the PDFs, TXT files, whatever, to actually come up with a test data set. But in this case, you can approach it slightly differently, where you use first excerpts from this document as correct answers, and then you try to formulate the questions that will be answerable from these source documents. And this way, you can arrive very quickly to a sort of ground truth the data set with expected questions and expected answers. And of course, you can actually use LLMs here with a human review, and that is some of the components that we implemented in the Evidently open source library. And there are a few other tools that can help you do this, which I find fascinating. Because, for example, if I were to create a set of correct answers and questions about Evidently, even though, of course, I know them all when I see them, I cannot actually come up with so many questions myself. But using synthetic data, it can generate hundreds of questions and then just choose the best ones. In this way, have a very diverse test data set that I will be evaluating my RAG system on. And then once you have this ground truth data set, you can perform these evaluations where you compare the answers you get against the expected ones, either using LLM Judge or maybe sometimes using simpler methods like semantic similarity, of course, with its own caveats on whether you can capture different nuances this way. So here's again an example. I think it's very similar to the one I shared, where we use the correctness judge between the target response and ideal response, and we use the LLM Judge reasoning. And when it comes to the open-ended evals, the same things apply. And with RAG, a very interesting approach that you can use, even when you don't have the ground truth answer, you still have additional information that is available for you at the moment when you generate this answer. And you can use, for example, the context that was retrieved and the answer that you got to check for hallucinations, where you essentially use an LLM Judge as a way to double check, like, are there any contradictions between the generated answer and the source document that we retrieved? In similar way, you can look at other dimensions, like, for example, the relevance of the responses to the question that was asked, or maybe answer completeness, like, do you completely fully answer all the nuances based on the context that was retrieved, and so on. So, of course, the type of criteria that you might want to focus on can be adapted to your use case. In some cases, if you can look at something like tone or conciseness, even if it's the RAG system, you still want to communicate the answers in a certain way. However, many things are quite generic, and something like faithfulness check, I think it's very universal. So it's a good way to notice when, for example, you might notice contradictions between the generated answer and the source document that was retrieved. Very quickly, some takeaways that I wanted to leave you with before we go into demo. I know it sounds like a lot, and that's, as I mentioned, because it is, right? So if you want to design good evaluations, you actually need to invest in this, and someone has to take it over. Sometimes it's a product manager, sometimes it's a developer, sometimes it's a joint effort, but you cannot just like coast and assume that something will happen automatically. Evaluations do require some work, so you need to allocate it and have an owner. And we still need the data, even though you're not training machine learning models, we still care about the data here. In this case, that's the test data set that you might be using to evaluate and test your systems. And you might actually want to have multiple test data sets that you're going to be using, for example, with expected questions, which are like happy path questions, and maybe some tricky edge cases, and maybe some adversarial queries. So you might actually end up having multiple test data sets. And last but not least, you always have to look at the data. So you cannot just like automate it and outsource it without ever looking at the result. You first need to be the judge before you start with automating this. But the point is, you still have to start somewhere, and I think Emeli can show us some very simple example as a quick demo for now. So now I'm going to take a pause, and Emeli, hand it over to you.
Thank you. It was super interesting. Now I'm going to show you some code and hopefully some applications. Let me try to do that. A little bit of learning how to work with Google Meet. Now I'm going to share like the whole browser. Please let me know if it works or not.
I can see me.
Oh, that's the plan. Lovely. So now let me switch to the code part. It's supposed to be working, right?
Yes, we can see it.
Lovely. So yeah, now let's try to do some code example here. And what we are going to do is we are going to create a very simple RAG-based application. Basically, that's going to be just a simulation function to see how we can retrieve some information from our documents in order to augment our assistant with the relevant context and then generate answer based on this context. And as we mentioned before, both me and Elena are co-founders of Evidently. So for simulation, I'm going to use some documents like API reference for Evidently, so that I can create an assistant which is potentially can be used by the users of Evidently to help them to write code more efficiently and learn more about what metrics and tests we have. So that's the basic things. I'm going to work with Jupyter Notebook. That's my local one, but same things pretty much works for Google Colab. If you also do work internally, I mean on your local machine, it's always good to use virtual environments because I'm going to install quite a lot of libraries. So I already have my virtual environment working. Then I need to install quite a lot of things like Evidently, LangChain Community, OpenAI, and Facebook AI Semantic Similarity Search for CPU. Just leaving all these instructions for you in case you did not have it in your virtual environment and need to install it as well. For me, it's already there. And yeah, we're going to need quite a lot of tools to simulate our RAG system. So together with the standard libraries like random, requests, OS pandas, we are going to import also quite a lot of things from the LangChain. I'm going to comment on that later, exactly when we are going to be using that. And also, evidently for evaluations, I'm going to use datasets, reports, quite a lot of descriptors and metrics. So I imported quite a lot of things there. For LLM provider, I choose OpenAI. Here is my client, and I have my API key in environment as environment variable, so I can just go for this command. And very similar to Evidently, because I'm also going to generate some synthetic data here, so we would need to be able to connect to Evidently from Jupyter Notebook. So basically that's it. Now moving to the actual development part. And I personally really like the principle of test-driven development, where we first think about how exactly we are going to test this or that function, and then we move to the actual implementation. And as Elena told us before, it's always great to have a data set, even if you don't have any production logs yet. You can kind of create the potential questions which, for instance, your users can ask from your assistant. And then by doing that, you could create some questions, some reference expected good answers. And after you create this data set, you can check every single iteration of your development that the question you generate with help of your new assistant or RAG system are good and similar to what you actually expect to have as the reference answer. Let us try that. So I already have a project at Evidently. Let me quickly move here. And my first task would be to come up with the synthetic data sets, because I'm just starting my development and I might not have any data set yet. There are several ways how you can do that. So maybe the most straightforward way would be just create like a Python list or Python dictionary with questions and answers and just write it yourself. But as all developers, I'm quite lazy to do that. So I'm going to try a synthetic automated data generation. For doing that, it's like my project. Here it is. And I basically go to the data sets. Where it is? Here it is. And I'm going to generate data set with AI. Hopefully I have all the tokens here. And let me just create questions and answers from documents. I would need to generate the name for my dataset. I'm going to be very, very quick. Questions and answers. OpenAI works for me just fine. Maybe, oh, there are so many models. Maybe I should try GPT-5. And as I'm going to generate, oh my God, that's going to be hard. As I'm going to generate some questions based on my documents, I need to have some document to do that. Oh, please help me. Yeah, maybe I'm just going to drag and drop something that I have. Yeah, it's LLMs who sm.txt. Basically, that's the documentation of Evidently, which is publicly available, but in text format. So here it is. And I think I'm just going to go with the default options. No specific scenarios, no criteria for user profile. Yeah, I think let's try to go like that. Of course, it's much better when you specify some information about who is your target user, what is the scenario of application usage, so that you can generate the better questions. But for the sake of speed, I'm going to just go like this. Generate dataset. So now the prompt for generation of my dataset is working with the OpenAI because that's the provider I selected. And after it generates all the questions with answers, it will give me a link to a dataset so that I can see the questions, I can agree or disagree, and then use it for my testing purposes. So let's wait a little bit. It's supposed to be quite quickly, especially if your document which you use for the dataset generation is not that big. Yeah, allow me a few seconds more. And I believe it's going to be ready very, very soon. Maybe let's just go and see what's going on there. Oh, it's working. But luckily, I have my previous task already generated, so I think we can go and check the previous dataset while we are waiting for the current one. Lovely. So let me go for some testing dataset. For instance, this one. And that's exactly the example of the questions and answers which you can generate based on some documentation provided. So basically, there are very nice questions related to the metric which we can use for sentiment analysis, some information about the ensuring that the response have a specific length, data definition, text evaluations, very nice. Actually, we can pretty much go with this data set and use it as a basis for our testing. So I'm going to just quickly copy dataset ID for the further usage, and let's return back to our code. So now I'm just going to copy the dataset ID here. Now I can load it back to Jupyter Notebook by doing just client load dataset, and client is here, so we just created it one step before. And now let me set some options for pandas and explore dataset as the pandas data frame. So you see it's very similar. We have the column with questions, we have the column with answers, and that's the expected answers which we believe are correct because that's how we generated those answers with help of our synthetic data generation. So nice. Now I have everything I need to test the quality of my RAG system, and I can pretty much proceed for RAG system implementation. Well, I'm going to be very brief here, and we are going to use pre-built functions for pretty much everything. So first of all, I'm going to generate the vector store, which is basically a database where we can have all the information from our documents, PDF files, articles, and what's not in the chunks format, so that we split our data into small chunks. We also associate a vector with every single chunk so that we can later do similarity search and select or retrieve relevant part of our knowledge base to answer a specific question. That's what is going to happen based on our vector store. And to implement that, I have the following function. So basically, my first step is to load my data to generate the vector store. In my case, I'm going to just use a URL, the public one, with the documentation for evidently. So with help of requests, I just get this data. Then I have this command to show me an error in case I have one. And basically, after I loaded all the web page, I just parse the text from there, from the response. Then I would need to split my response, my text data to some chunks. And here is the splitter. I use the ready-made model for doing that. The chunk size will be equal to 800. Again, that's a parameter which you can tweak in order to get the best quality of your RAG system, and some chunk overlap. And again, those are parameters which you can evaluate based on the quality of your answers. I'm just going with the default ones. Maybe the other values would be better. So that's how I'm going to split my text, right? Then the documents. Basically, I create the documents from the content which I parsed from my URL with evidently documentation. And finally, I'm going to split those documents into smaller chunks with some overlap. As soon as I have the list of my chunks, I can create some embeddings. And for doing that, I use OpenAI, basically because I have my keys, right? And finally, with help of Facebook AI semantic similarity search, I'm going to generate vector store based on my chunks and embeddings. So basically, I'm going to use embeddings to do similarity search. And as soon as I found some relevant chunks, I just used raw text to send it as a context to my LLM to generate some answers. So that's the function. Also, the search itself is super similar. Basically, I need to have a query, a question of my user, and the vector store. And as soon as I got my query, I can go for my vector store and ask to do some similarity search. Let's not ruin that. And I can select how many relevant chunks I need to retrieve. For instance, like that a bit more. I think it's going to be a bit better, right? And as soon as I retrieved all my similar and relevant chunks, I can just unite it by the empty string. Why so? Just because I need to pass it as the context to my LLM, so I don't need to have any specific structure here. So just united context will be enough. Again, it's very simple RAG system. Maybe you can do better. Then, yeah, that's how I'm going to search for documents. When it comes to generating a response, that's super simple again. I need to have my question, I need to have my context, and for getting context, I already have this similarity search function, which helps me exactly with that. And I'm going to use GPT-4o mini just because it's fast and pretty lightweight compared to the other options from GPT. Right, so that's the implementation. I go for my OpenAI client. I use responses API, the newer one, and I just go for create method, which basically the following. Here is my system prompt. It's called instructions there, and I say that your task is to answer the provided question based on the retrieved context. Basically, that's it. Here is the model from here. And I also say that the retrieved context is, and then I want to place everything I retrieved. From where do I get this context? Basically, before this function, I call this function and pass the context here. Or if you prefer, so you can even call this function inside of this one. That's also possible, 100%. So let me run it. And yeah, as I promised, I'm going to use the documentation for evidently publicly available one to generate my vector store. It's going to be super quick because it's just TXT files. And yeah, we have so many chunks, but you see it was super quickly. That's ready. Now I have my vector store, and now I'm ready to generate some answers for my questions. So let me create the array with questions. Basically, I just take the values from the question column of my data frame. Then I'm going to generate some context. Again, it should be quite fast because I'm just doing this similarity search for my ready-made vector store. And finally, I'm going to use this function to generate some answers based on the retrieved context and questions. I have just 5 questions, so it's supposed to be quite quick iteration. So 5 times I need to go to OpenAI and ask to answer this question with respect to retrieved context. So I believe it's the most naive and simple implementation of a RAG system. Generally, you have more than just one TXT file to build your vector store, so I guess you would need to write a bit more code there, but the principle is super similar. So yeah, now my answer is already generated, so I can move to the evaluation. And I believe the most straightforward way to evaluate the quality of your generated responses or answers is just create your data frame and read it manually, because you are an expert there, you understand what are the questions and answers, and I believe if you just read one by one, you can generate some intuition about the quality of your system. So let me do that. I'm going to create a brand new data frame with questions, some reference answers, which were derived from the initial data frame, right? But now I'm going to rename it. It's like a reference answer so that I can differentiate it from my generated answers and the context of cast. It might be useful for evaluation. And that's how my data frame looks like Oh, that's huge. But yeah, so here is the question, like, which metric is used to check for negative sentiment values in the response? Nice question. Here is my answer. So it tells me that the metric, yeah, so the sentiment. Okay, interesting. Now the reference answer. Again, yeah, it's about sentiment, but it also includes some information about how exactly to check that from the evidently code example. Nice. So yeah, I think that's how we can analyze the questions and answers one by one, but there are quite a lot of contexts, quite a lot of questions, and definitely we need some automation there. How do we do that? With some LLM as a judge and other metrics to be selected for our specific case. So I think I would go from the contradictions check because I have my reference answer, I have my generated answer, and the most straightforward check I could imagine is to just compare one to the other and check whether my reference answer is kind of similar semantically to what I generated with help of my assistant and vector store. So the idea here is that I need to come up with some criteria to my LLM as a judge. And basically I say that please label my answer as contradictory only in case it directly contradicts any part of the reference. And this is up to you how exactly you frame that. Because I say the differences in length or wording are acceptable. You might say, no, it's not acceptable. And in this case, it will be your specific contradiction check criteria. Mine is kind of flexible. So I only look for direct contradictions, and that's how I phrase it. Also, I say that there is the labels I want to use as the results of evaluations, contradictory or non-contradictory. In case my LLM as a judge is uncertain about an answer, I ask to say unknown, and I want to have some reasoning so that I understand why the particular generated answer was labeled as contradictory or non-contradictory. And basically, that's it. So now I can create all the evaluations I want. I use my custom criteria for LLM as a judge. Here it is. So here, let me just comment what's going on there. I'm going to create the new data set based on my testing data frame where I have questions, generated answer, reference answer, and like a context. And I'm also going to add to this data set some descriptors, some statistics generated for every single row of my data. How do I assess the quality of my assistant? Basically, I want to check the sentiment of the generated answer. I prefer it to be non-negative. The length of my answer, maybe I can generate some expectations on the length, some faithfulness, its pre-built LLM evaluation, and my custom LLM judge for contradictions. That's exactly what is happening here. So I'm going to estimate all those statistics row-based on the whole frame mine. Now it's done, and let me quickly show you how it looks like. So now together with initial question, here it is, answer, reference answer, and context, I have those all pre-built metrics. Again, so a lot. We can see that it's faithful, we can see why, we can also see that it's non-contradictory, again, some reasoning and other statistics. But again, observe it one by one is not very handy, especially if you do have like bigger data set. This is why I quickly moved to the report from my raw data. And now I have all my statistics aggregated. So now I have the distribution for my sentiment, and surprisingly, there are some negative sentiment, but not that much, so mostly neutral. Also, I have the distribution of the length of my answers. So it starts from 241 to pretty long, wow, 1,600. So yeah, there are quite different answers and lengths. Mostly faithful, only one unfaithful answer, and wow, 3 out of 5 contradictory. So basically, I would need to tweak some parameters to make sure that maybe I can get some better results, right? So that's how we can perform some local validation and analysis. And let me just quickly show you that in case you do want to maybe store the results of evaluation somewhere, you can go and edit to to the cloud so that later you can share it. For instance, I can share it with Elena, and maybe she will be able to read through that and give me some comments about that. For doing that, I'm just going to send it to the cloud. And here I have a link how I can browse it. The next thing is that here you can see the report and data set all together, and maybe in the same time read for the raw text data and browse the statistics. So yeah, finishing right there. Maybe we can squeeze a couple of questions if you have any.
I think there were a couple of questions left in the chat. Samuel, Sion, should we comment on that, or how would prefer us to proceed? Okay.
Hi, Elena and Emeli. Thanks for the wonderful session. I don't know if Sam is having an internet issue, but I hope you can hear me.
Yes, we can hear you.
Yeah.
Okay, so that was an amazing session. So I think we can have been discussed over in the chats. So I guess we just probably start from there. If anyone has any questions from what has been discussed so far, kindly drop them in the chats. So that in the next couple of minutes, Elena and Emeli will just go over them. But yeah, Elena or Emeli, please let's start with the first question from David. I think he's asking questions around limitations of LLMs as a judge, and maybe other possible workarounds. So yeah, let's start from there.
Yeah, so the question is like, do you think LLM won't be biased in its judgment? Why don't we look at a system outside LLMs to judge LLMs, like Blue, Levenstein? What are the limitations? Well, there are a couple of limitations. The major one is when we talk about metrics like Blue and Levenstein, it does require you to have a reference answer, right? So this is the metric that can only work when you're comparing the answers against the reference. And in this case, these metrics would actually look at the overlap in symbols or sequences, but they will not look at the semantic match. And in this case, yes, LLM judges are not perfect, but if you look at an example like Emeli showed, when you essentially ask an LLM to check if there are any contradictions between the two texts, this can actually work much better than something like Levenstein, which will only tell you like how many symbols of difference are between the two texts. So in this case, LLM judges are not perfect, but they're very useful, and especially for open-ended comparison, because when it comes to open-ended judgments, we literally have no other options. You can either look at it manually or try to create the best judge you can. And there is no metric that can tell you if the responses are correct when we don't have reference. So yes, there are downsides. LLM judges are not perfect. They require evaluation, but they are a very valid approach. I don't know, Emeli, do you want to add anything here? No. We also have one question. What if we have a classification system where we compare output and ground truth? You are in luck. That's the best use case you can have, because in this case, there are a lot of metrics like accuracy, precision, recall. So nothing changes here from classic machine learning. You can just compare the answers you get against reference and quantify it. If it's like multi-class classification using like multi-class metrics, but essentially same things that worked in machine learning. You don't need an LLM judge there. That's the good part. Emeli, I think the next one is to you. What's the performance trade-off of continuously logging embeddings, large vector data for drift detection?
Well, that's a good question. Luckily, nowadays, we can store quite a lot of embeddings for very, very cheap, I would say. And well, the good thing is that whenever you create embeddings, you can decide on the size of those vectors. It can be bigger, it can be smaller, depends on how much memory you want to spend on that. And actually, if you're, for instance, implementing the RAG system, you would need those embeddings to generate a vector store and then look for similarity search. And the good thing is that you can reuse the same embeddings to do some drift detection. So yeah, honestly saying that's going to be some trade-off, because if you just store the raw text data, you spend less memory because you don't have any embeddings. But embeddings are numerical vectors which can be stored very efficiently nowadays, because we can compress it heavily. and there are specific databases which can do it very efficiently. So I would say if you need to do some data drift detection, it would be even better to create this embedding representation of your data compared to detect drift based on raw text data, because further saying, the drift detection based on embeddings is much quicker in terms of CPU usage, and I think it's worth it.
The caveat is to have enough data to actually detect drifting. We have one more question. Please explain the importance and use of human evaluation and auto-raters. Well, I think we can write a book on the subject, but the quick answer would be auto-raters and automated evaluation is a way how you scale your human judgment. So before you do that, you need to figure out what you actually want to evaluate. And in many scenarios, you need to bring in domain experts, look at a lot of the data, and try to figure out what actually matters for your use case. And until you figure out that and nail down your criteria, there's pretty much nothing to automate. The mistake that many make is like they try to apply a lot of metrics out of the box, like conciseness, sentiment, something like this. But if it doesn't matter for your use case, you will not actually get any meaningful signal. Your goal is to figure out criteria which is discriminative. That's something that helps you understand if you're actually doing good or bad, right? And help you compare, for example, between prompt versions. So starts with looking manually at your data, figuring out what matters, involve domain experts if it's like a medical, financial, legal, healthcare domain, and then figure out how to automate it. That will be the TLDR on you need to look at the data. I don't know, Emeli, anything to add?
Well, maybe just a small observation that if you're not certain about what is the good result of your system and what is the bad result of your system, it's always good to start from reading data manually and attract some human experts to create for you the first labeled data set, and then you would be able to automate it. And in this case, you can treat this human experts as someone who create for you like the first data set, which you can be using later for training your LLM as a judge, for instance, like that. That's also an option.
And I'm not sure I understand the last question from David. Maybe if you could clarify. For canonical use case, how can we use LLMs, which is basically a probabilistic search engine? So I'm not entirely sure what the question is about. How can we use LLMs for search? Well, we should not, or is it not the question?
Hi, so sorry, Elena. Let me see. Hi, David. Do you mind using your mic just so Elena gets your question properly? Do you mind using your mic? Hello, David. Oh, okay, okay. Oh yeah, hi Zion. Please go ahead.
Yeah, so I mean, I would want to assume that David might be asking about the trustworthiness of LLMs as, for evaluation, given that they are probabilistic in nature. So how can we trust them to factually be able to evaluate systems and accurately be able to act as a judge? I think that's kind of what David has in mind.
I would say the trick that we should not rely on them for factual evaluation. So when we're talking about LLM as a judge, we're talking about evaluating some other properties like this, for example, finding contradictions in text or identifying sentiment of text or figuring out if a certain pattern is followed. And these are the tasks that LLMs are pretty good at because they've seen a lot of text during training. So yes, there are some things that you should not use LLMs as judges. For example, you shouldn't ask an LLM, hey, is the response correct? Without any other further information, right? So of course it will say something, and maybe sometimes you can actually do this, but you should not trust that. But we're talking about nailing down the criteria in a way that can be actually outsourced to an LLM, or providing additional context right inside the judgment so that LLM, for example, look for contradictions to the context. So I think you're absolutely right in mistrusting LLM as factual information providers, but when you talk about using LLM as a judges, we're actually trying to avoid that part and focus on the evaluations that can be performed. So imagine like reading through the text and try to identify if at any point in the text, the person expressed frustration. That sounds like a task that LLM could do. If you play it with LLM, I'm sure you can actually trust that LLM can identify some negative sentiment. And this is the type of judgment that you can actually outsource. Instead of yourself reading through all the logs and conversations, you can ask the LLM to flag the conversations where people were expressing some unhappiness. So in this case, the LLM judge can actually be even better sometimes than humans, because humans get tired of reading the text, right? So you cannot always trust that. But you are absolutely right. You should not, when you talk about LLM judgment, we're not talking about using them for factual correctness check, unless you use an agent that actually goes and fact checks using some sources that you provide to it. I think that was it. That was the last question in the chat.
All right, awesome. Hi, David.
Yeah.
Please confirm that you're good. Please confirm your question has been sorted and you're good. All right, awesome, awesome. Does anyone else have any question? Okay, so I'd like to believe that there are no questions, right? Thank you very much, Elena and Emeli. This has been super, super wonderful. I really did learn a lot from you. And on behalf of the entire AISOC community, I want to sincerely thank you. And thank you, Elena and Emeli, for this very, very powerful and insightful session on LLMs and RAG evaluation. I think it was very, very exciting for me, right? Getting to see the whole thing. First off, I loved your presentation with your slides, and then I also loved what Emeli did as well. And that was really, really great for me. So you both have not only deepened our understanding, but you've also given us practical perspectives that would help shape how we get to approach projects moving forward, right? We thank you very, very much for the time you took to share your expertise with us. And I'm sure everyone here on the call as well has taken away really, really big, valuable knowledge, right? Thank you once again. And we look forward to learning more from you. Everyone on the call, please, when you look in the chat, you should see their Instagram links. Please, LinkedIn rather. So sorry about that. Their LinkedIn pages. Please do well to connect with them on LinkedIn. There is going to be a whole lot to learn from them moving forward from here. Right. Thank you very much, Elena and Emeli, once again. We really do appreciate you.
Thank you very much for the invitation, and good luck, everyone.
Right. Thank you. Bye, and have an amazing day.
Bye-bye.
Bye-bye.